All right, let's talk about a true game changer in the world of AI, ResNet50. This thing is a huge reason why the AI in your phone, in modern cars, and even in hospitals can recognize images with just, mind-blowing accuracy. So let's get right into it.
You might have noticed this yourself. For a long time, AI was just okay at recognizing images. And then it felt like almost overnight, around 2015, something just clicked. It got really good. So the big question is, what happened? What was that secret sauce that let machines finally see the world almost as well as we do?
Well, to get to that answer, we have to talk about a huge problem that researchers were running into. They had basically hit a wall, and a really weird counterintuitive one, in their mission to build smarter AI.
Now, the logic at the time seemed totally straightforward. An image is complicated, right? You've got pixels that make up edges, and edges that make up shapes, and shapes that make up objects. So to get that, you'd think a neural network would need a lot of layers, too. More layers, more depth, that should equal a smarter network. At least, that was the theory.
But here's where things got really bizarre. Researchers would build, say, a 20-layer network, and it worked pretty well. Then they'd build a 50-layer network thinking it was going to be way better, but it actually performed worse. Adding more layers was somehow making the whole system dumber. It just didn't make any sense, and it had the entire field kind of stumped. The bad guy in this story has a name, the vanishing gradient problem. See, when a network is training, it sends an error signal backward through all its layers to help it learn and adjust. But in a really deep network, that signal just got weaker and weaker the further back it went. By the time it got to the first few layers, the signal was so faint, so distorted, that it was totally useless. It really is the perfect analogy. It's like a game of telephone, where the message is complete nonsense by the time it gets to the end of the line.
So, this deep learning wall, it seemed pretty much unbreakable. But then, a team of researchers came along with an idea that was just so simple, so elegant, it changed absolutely everything. They found a brilliant shortcut.
So here was the big aha moment. They realized that forcing a network to learn an entire complex image from scratch in every single layer was just too hard. So they flipped the question. What if the network only had to learn what changed? What if, instead of learning the whole thing, it just learned the residual, or, the difference? That's a much, much easier job.
So let's look at this side by side because it really makes it clear. A traditional network, on the left, tries to learn this whole complicated pattern, and it loses information as it goes deeper. But a residual network, or ResNet, is way smarter. It basically takes the original info, passes it along, and says, hey layers, your only job is to figure out the small adjustment we need. Think about it, it's way easier to learn a tiny change than to learn a whole new identity from scratch.
And they pulled this off with a super clever trick called a skip connection. Okay, imagine the data moving through the layers like it's a message being passed down a line of people. The skip connection is like someone taking the original perfect note, walking past everyone, and handing it directly to the person at the end. That way, the original message is perfectly preserved, and all those layers in the middle just have to add their small tweaks. Just like that, the game of telephone was over.
Okay, so that's the big idea, the core concept. Now, let's actually peel back the layers and see how this brilliant idea was built into the model we all know as ResNet50.
And that number really says it all. ResNet50 is a deep neural network with 50 layers. Yeah, 50. A depth that was basically impossible to train just a short time before was now not just doable, but incredibly effective. All because of those simple little shortcuts.
So how do you even build a 50-layer network without it becoming a total mess? Well, you use a repeating pattern, like Legos. ResNet50 is built from a specific type of building block, stacked over and over again, called a bottleneck block.
Each one of these blocks has a three-step job. First, it uses something called a one-by-one convolution to squeeze the data down and make it simpler. That's the bottleneck. Then a more traditional layer gets to work processing the key features in that now smaller, more manageable dataset. And finally, another one-by-one convolution restores the data back to its original size. This reduce, process, restore pattern is crazy efficient, and it gets repeated 16 times inside ResNet50.
So let's look at the quick specs. ResNet50 is built to take a standard 224 by 224 pixel color image. On the inside, it's got those 16 bottleneck blocks, bringing the total layer count to that magic number, 50. Out of the box, it was trained on the huge ImageNet dataset, which means it could already identify 1,000 different things, everything from a golden retriever to a sports car.
Now, this wasn't just some interesting idea in a research paper. ResNet didn't just solve a tricky technical problem, it literally unlocked a whole new era for AI and what it could see.
And the proof? The big moment.
came at the Major League ImageNet competition in 2015. After years where progress had kind of stalled out, the ResNet model came in and just dominated. It completely shattered the old records. That was the moment the entire AI world realized that the deep learning wall had finally come crashing down.
And you can see its legacy absolutely everywhere today. Seriously, ResNet is the backbone of so many things you probably use every day without even thinking about it. From simple photo tagging and Face ID on your phone, all the way up to complex object detection in self-driving cars, and even helping doctors analyze medical scans, it's everywhere.
So if there's one thing to take away from all this, it's this. That simple, elegant idea of the skip connection solved a massive problem, and for the very first time made it practical to train these incredibly deep, incredibly powerful AI models. It basically taught machines how to learn from depth.
By letting networks finally go deep, ResNet completely changed our relationship with AI. It turned it into a tool that can actually perceive and make sense of our visual world. And, that leaves us with a pretty exciting question for the future. Now that we've taught machines how to see, what will we teach them to understand next?